Hello, welcome to our Scale Drawings Review, Lesson 1. Today we're going to find the actual dimension. A few weeks ago we completed lessons on scale drawings, so let's review some vocabulary. So first, we want to start with this sentence. A scale is a relationship between the measurements on a drawing or model and the measurements of a real object. Next, scale drawings or scale models represent something that is too large or too small to be drawn to actual size. For instance, if I wanted to draw a football field, I would not be able to fit a football field on a piece of paper, but I could certainly draw a model of it on a piece of paper. Distances on scale drawings or scale models are proportional to the actual or real-life distances they represent. Now that we have more knowledge regarding proportional relationships, we will review several different ways to calculate the scale model measurement or the actual measurement. In fact, we can use 3 different methods, and there may be more, and you can choose which one works best for you. We'll demonstrate this using past exam questions, so please take notes. So here we go. Our first question says, the drawing of a building shown below has a scale of 1 inch to 30 feet. What is the actual height in feet of the building? And our first method is going to be write and solve a proportion. So first let's highlight what's important. They gave us a scale of 1 inch to 30 feet. 1 inch being the model, 30 feet being the actual. And then the question they ask us is the actual height in feet. So if I look at the drawing, they've given us 2 dimensions, but we just want this height. So we're going to start by using a proportion. And when I use a proportion, I usually use the scale as they give it to me. So they gave me 1 inch, and labeling is important, and 30 feet. A proportion is 2 equal ratios. So now what I'm trying to find is the actual height, but I do know the height on the model, and it's 1 25/100 inches. And what I'm trying to find is the actual height in feet. So we don't know that. We're going to use x as a variable, or you can choose another variable, h for height, a for actual. We're now going to cross multiply using the butterfly method. That would be 1 times x. Butterfly body reminds us to bring down the equal. And 30 times 1 25/100, or you could write 1.25 times 30, whichever you prefer. So now we have 1x equals 37 5/10, which 1x is the same thing as x. So now let's look back and see what we just found. We were asked to find the actual height, so the actual height of the building would be 37 1/2, or 37 5/10 feet. So now let's go on to the next method. So this is Mrs. Nord's method, and she uses just the scale just a little bit differently. We still have the same bit of information, or given the same pieces of information we're working with. Then she chooses to put that information in a chart. So the first information is the scale, and the second information talks about the actual. And she puts the scale measurements in this chart. She then converts the scale measurements to a unit rate, and she does that by taking the actual measurements over the scale measurements. And what she gets is a unit rate. Then she goes back to the problem and fills in the chart with what is given. And what is given is the scale measurement. And if you move to the actual, then she has you multiply by the rate. So we would get 37 and 5/10 feet. So that's another method you can use to do this. Let's look at the third. The third method uses an equation, and this rate is the unit rate. We're just going to use an R times the scale model, and since S is not a very good variable, we're going to choose to use times M for model, and that equals the actual. So we could write that as rate times the model equals the actual measurements. So we start just like Mrs. Nord did, finding the rate, unit rate, and in this case it was 30 feet over 1 inch, and that means that that would be 30 feet per inch. So the unit rate would be 30. Now if we're going to use this equation, we're going to substitute what we know, and we know the rate now is 30. We know the model measurement was 1 25/100, and that will give us back the actual. So when we take 30 times the inches, it's going to give us back the feet, which is 37 5/10 feet, or 37.5 feet. So now let's move on to the next problem. This is another exam problem. So let's see how knowing these three different methods to find the actual measurement could be helpful. Howard has a scale model of the Statue of Liberty. The model is 15 inches. The scale of the model to the actual statue is 1 inch to 6 2/10 meters. Which equation can Howard use to determine X, the height in meters of the Statue of Liberty? So in this question, they're not asking us to find a dimension. They're asking us to figure out which equation could help us find that. And if you notice, A and B are traditional equations, while C and D are proportional equations. And that was, I thought, made this problem unique. So let's look at the problem and see what they've given us. The model is 15 inches tall. The scale is 1 inch to 6 2/10 meters. And they want to know which equation, not the answer, but which equation can be used to determine X, which represents the height of the statue in meters. So let's start, if we could, with the proportional method. So when I draw a proportion, I usually use the scale as is. So since they've given me the scale as 1 inch and 6 2/10 meters, I'm going to look back and see what I know. Well, I know that the model is 15 inches, and I don't know the height in meters. So that's a proportion. And if I look, I see that proportion in letter D. So we think that D might be our choice. Now we'll come back to this proportion method in just a minute. Next, let's use the chart method. Mrs. Nord would take a unit rate. She would put the actual measurement over the scale measurement, and in this case we get a unit rate of 6.2. Then we would build a table or a chart, and we're talking about inches for the drawing and meters for the actual, and then we look to see what we're given. Well, we're given 15, and since we're moving across to this side, we would multiply by 6.2. And we don't know it right now, so I'm going to stop with this X. So the equation that would be generated from this is 15 times 6 2/10 equals X. So now let's stop and see what they've given us in A and B. I see 15 times X, and I see 6 2/10 times X, but I do not see 15 times 6.2, so I don't think those equations are going to work. Let's just double check one more time. Let's work with the actual equation. So if we're working with this equation, we would put the rate, which we know is already 6 2/10. Then we would multiply times the model, which we know is 15, and that would give us the actual, which we don't know right now. So this equation is 6.2 times 15. So it's just the reverse of the one we had in the chart method, and neither one of these work. So these we can eliminate. We already could tell through our proportion that this was actually the equation that we needed to use. If we continued this, now real quickly I want to go back to this proportion. If we continued and cross-multiplied this, we would end up with 1 times x, and then 6.2 times 15, our reverse. And we can see that this is very similar to the other equations we have, just flipped on the other side of the equal sign. Thank you for listening. Would you please now go to the practice sheet, practice 1, and try this skill yourself.